Hello again. My name is John Gabriel, and this is the new Calculus channel. In this video, I'm going to show you how to form your own differential equations. Isn't that neat? Yes, of course it's neat. So, in the previous episode, I showed you exactly what is a derivative and exactly what is a differential equation. So now, you don't fear differential equations any longer. They're pretty easy, and we're going to figure out a very nice differential equation, very nice, but pretty useless, in fact, differential equation in this video today. So let's begin. So how can you form your own differential equation? Well, let's see. Click on there. It's easy. Just think of any function that has several derivatives. How about y is equal to x times e to the x plus sine of x, okay? So by the way, y here is a function of x. And let's say that we're going to take the third derivative minus the second one plus 2 times the first derivative minus twice the first function. And the result is what you see on the right-hand side here. And you can check that this equation is true by taking the function, finding the first, second, and third derivatives, and doing the little bit of arithmetic that you see on the left-hand side to get the right-hand side. So this broken green curve is actually the right-hand side, 3 times e to the x minus sine of x plus cos of x, right? And just to make sure that I was on the right track, I decided to test this. So I placed a little point here, and I move it along to see if the green curve is indeed the right-hand curve, the right-hand side of this equation here. So now, typically, you are not given this particular original equation here. You're only given this equation here, and you're asked to find y, which is, in fact, this particular equation here. So you can there are many ways to solve differential equations, and you can solve them using series and many other methods. And of course, the most common method to solve them is through numeric integration, okay, because you're trying to find a function that which when differentiated will give you the original function you have. Or in this case, if you have to integrate this here, the green particular function, you should actually get back to the original blue function. Now, I don't know if I said that right, but I think I did. But if I didn't, most of you do know what I mean. So let's see if Wolfram Alpha, the computational engine, gives us the correct answer. So if we go to their website and we type in, we ask it to solve this differential equation here. So Wolfram Alpha now doesn't know what y is, right? And it chugs along and it takes the input, so we know that it's correct because we see over here that it interpreted the input correctly, and it gives us the differential equation solution as this down here. So this here is obviously wrong, even though it has constants here. And I'll show you why. Because this is the solution I copied with constants in the front. Now, obviously, if I put 0 constants in front of these two terms, they'll disappear, which is a good thing. And I'll have that and that, but this should, in fact, I could also make this e to the x disappear, so all of these disappear, but I still need this term here to disappear, and there's no constant in front of that one. So if you look over here, there's no constant in front of this term. So that's obviously wrong. And there's no constant here, which I can change so that it gives me exactly this particular term. So obviously, Wolfram Alpha didn't find the solution correctly. And I thought I might have been doing something wrong. So I decided to try some simple equations, like, for example, this one here, which I know the answer must be the function x squared, yeah? Because if I take the derivative of x squared, it's 2x, and 2x minus 2x is 0. So it does, in this case here, find the correct solution and adds a constant to it, which we can just ignore, because when we differentiate the constant, we'll have the first derivative, okay, which is 2x. Now, I tried it also with a slightly more complex equation, this one here, and it found this answer here, but C1 would definitely have to be 0 in this case. And so it's obviously wrong. And this is a warning to those who come to Wolfram Alpha Computational Engine and type in queries and just believe they're correct without actually checking them. So this is the way you can form any differential equation. You simply take an original equation, which you know exactly how it's defined, and then you differentiate it, if it can be differentiated, a few times. And then you look at that last result and ask yourself how you could find the original result through integration, right? And it's very difficult, obviously, especially if you have an equation like this. So I hope you've enjoyed this little presentation. I've showed you how to construct a D. Maybe you can call yours the moron D equation or something else. I don't know, whatever you want to call it. And perhaps you can think about these things a little bit more and learn a little bit about differential equations to remove all the mystique about them, because there's really nothing difficult about DEs. Ironically, most mainstream academics never actually understand them because they're working with a flawed calculus. The mainstream calculus is broken beyond repair. So anyway, this is the New Calculus channel, and I'm John Gabriel. Till next time, goodbye.